Welcome to another podcast. In this episode, we're going to be taking a look at reversing the process now. For the first couple of videos, we've been doing things in one direction only, and that is I give you a function f of t, and you tell me what its transform pair in terms of the s variable is. Now I actually want to reverse this by asking the question, okay, what is the inverse transform of something like 1 over s minus 3. Well, you can immediately see that the inverse transform would be going in the opposite direction here, and I recognize 1 over s minus 3 as being a equal to 3 for this formula, so that would imply that the inverse transform here is e to the 3t. That one's pretty easy because we have a value here that's nice to look at. What if I asked one that's a little bit more difficult? What is the inverse transform of, let's say, the inverse transform of, let's say, 2 factorial over s cubed. That one's a little bit harder. You can see that that clearly goes with t to the n, and so that's when n is 2, so this would be t squared. Now what if I changed it up just a little bit? So now I'm looking at the inverse transform of, let's just say, 5 over s cubed. Now, I know that s cubed goes with t squared, so I know this is 5 times the inverse transform of 1 over s cubed. But 1 over s cubed is not going to fit this exactly right because it should be 2 over s cubed. Well, what you can do then is multiply by a 2 in here and compensate by dividing by a 2 out here. So that what you have is 5 halves inverse transform of 2 over s cubed. Remember, it's a linear operation, so its inverse is linear as well here. And what we have then is 5 halves the inverse transform of 2, which is the same as 2 factorial, over s cubed then would be t squared. So 5 over s cubed is the inverse transform of 5 halves t squared. Let's look at another one. What is the inverse transform of 1 over s squared plus 1 minus 1 over s minus 2? Well, linearity says it's the inverse transform of the first one minus the inverse transform of the second one. And I immediately recognize the second one. This is going to be e to the 2t. And this first one here is 1 over s squared plus 1. So it is going to be sine. Sine with a equal to 1. So you can see here if I let a be equal to 1 there, then that's 1 over s squared plus 1. So this is sine of at, or sine of 1t in this case. And so all these nice properties are basically just reversing what we've been doing in the previous video, but you have to know these pairs really well. In your mind, there has to be a connection that works both ways between these transform pairs, otherwise you're not going to be seeing properly when it comes to doing this problem. Now, what I would like to do in the upcoming video is look at a slightly harder inverse transform to do, and that inverse transform is going to revolve around partial fractions, and so you might need to go back and review a little bit of partial fractions for this next video. Alright, thank you for watching.